Hi everyone, my name is Lucy and we're back with another video. If you're new to the channel, you can just please subscribe and then just to show us support, and then you can also just click the notification bell. There's a notification bell thing there. You can just click it and then you basically get notified whenever we upload a video. Otherwise, we continue with vectors. So what we'll be looking at now, we looked at adding vectors. So now we'll be looking at subtracting vectors. So, and these vectors, we did look at a case where we're subtracting vectors that are in the same line. But now I'm more interested about vectors that are, let's say, like, they are not in the same line. So how do we go about doing that? Right? Okay. Can start with a simple case before we go to this case. For instance, let me say I have a vector and I want to find the vector A. Alright, let's call it vector C. You'll see why I'm calling it vector C. I want to find vector C. But vector C is such that it is made up of vector A, and this vector is, let's say it's 20 meters, and then plus vector B, right? And vector B is basically this vector. Let's just say it is 25 meters. All right, so we can agree here that, I mean, for us to find vector C will be given by and these ones are perpendicular to each other. So vector C will be given by A, which is a vector, and then plus vector B. However, what happens if I want a case whereby I say I want a vector D, but this vector D is such that it is equals to A minus B. Alright, so now it's different. Vector C is fine, we can find it, we know how to find it. I want to find vector C. Vector C is A plus B. So I've shown you how you can add that. Now the question is, what happens if I say, no, for the same configuration where I have vector A going that way, have vector B going out, but I want vector D, and vector D is such that it is equals to A minus B. Now, what do I do in that case, and how do I go about dealing with that case, for instance? Alright, so in doing that, let me just bring it back to screen. Alright, so in that case, you have to notice quite a number of things, right? Vector A, which is this one, vector A is going that way. That's where vector A is going. What about vector B? Vector B is going that way. So one way you can think of this is the vector that is going in the opposite direction has the same size as B. It's actually called minus B. Alright? Now you could simplify this equation and say, well, this is the same as saying vector A plus minus vector B. And I always teach students to try and approach this problem from this perspective. Why? Because we know how to add vectors. So since we know how to add vectors, it's much more easier for us to deal with when there's a plus. Then we can actually have a very conceptual understanding of what is happening. Alright, now let's look at this now. What is vector A? Well, vector A is 20. What direction is it? It's in the X. Okay, fine, that's good. And then there's a plus to it, that's plus. Put a minus, which is this minus. Now what is vector B? Vector B is 25, right? So you have a minus B, right? So the magnitude is 25, right? And then in the X direction. So this is 25 in the Y direction, not the X direction. I don't know why I say in the Y direction. So it turns out that, well, my vector D is going to be given by 20x minus 25y. Right? So that's one way you can do it. Alright? That's the way that you can actually approach this problem. And then if they wanted the magnitude and the direction of this vector, of course, then you would have to draw it. Let me say, for instance, they said to you, find this vector, so you have to find the magnitude and the direction of this vector. So in that case, because when you leave it like this, you are basically leaving it in component form. So, but then if they want the magnitude and the direction of the vector, then you continue it the way we used to do it. So you can find the magnitude of D. First, let's draw it. So this vector is 20 in the x direction. There it is. 20 in the x direction. So it's 20 meters, which is A. And then it is minus 25. So minus 25 is going down in the y direction. So this is minus 25 in the y direction. That's what the vector minus B is, in a way. So the vector D is a vector that actually looks like that. So you can draw it. So it's actually a vector that looks like that. And theta will be somewhere here, which is going to be opposite over adjacent. This is y over x, right? Because remember, that's how you're going to find the direction. Okay? So let's see how this works. So if I want the magnitude of D, I'll just simply take the square root of 20 squared plus 25 squared, and then I'll get the magnitude. Okay? Alright, so let's just calculate that magnitude and see what it is. It's 20 squared plus 25 squared, so that is 32. Okay, so the magnitude of that vector D is going to be 32 meters. The direction of that vector, you're going to say tan of theta. It's going to be whatever is on the y, which is 25, whatever is on the x, which is 20. Therefore, theta is going to be, by now you should know how to calculate that, so I'm just going to punch it in the calculator. And then this is 25 over 20, and then we get 51.3 degrees. 51.3 degrees. Now let's look at it now. How do we then write it? Now it is 51.3 degrees, but then you can see here, for you to actually get to from the tail to the head, you have to go to east and then south. So you can say, well, D is 32 meters, 51.3 degrees, and then you have to go east to the south, so therefore this is south of east. Remember, you just swap everything around. So I've explained all of these concepts. Or you could just say that it is 51.3 degrees below the positive x-axis, which is just below the positive x-axis, which means that you could put an axis here and an x and a y here. If you put an axis here, this becomes the x, this becomes the y, so you can see that it is below the x-axis. If you were to put an axis like that, it's going to be below the x-axis. Alright, so you could actually say it like that as well. So that's fine. That's how we can add everything when it's negative. Then what about when it's not so when it's perpendicular to each other, not negative? I don't know why I'm saying negative. What about a case whereby these vectors are actually not perpendicular to one another, right? So I have a case whereby I have the two vectors. Remember that these vectors, they can be asked in different ways. They can give them to you in component form, in coordinate form, or they can give them to you like the way I'm giving it to you now. So let me say I have vector A. Let's give it 30 degrees now, and then let's remove that on top, and then let's come back. So let's give it 60 Newton. I'm just trying to use simple units. Then let me say I have vector B. And let me just make things interesting now. I'm going to put the angle here, and I'm going to use that angle. So this angle, I'm saying, is like 47 degrees. Okay. Right, and vector B, actually, let me just give it a magnitude. If I give it a magnitude, and then we just work with that magnitude, and I'll give it a magnitude of shorter. So let's just give it a magnitude of 50 Newton. Alright, in actual fact, let's write it this side because it's going to come in handy while we have to write it that side. Okay, alright. Don't know why it behaves very strange whenever I try and erase. It doesn't make sense. Okay, 50 Newton. All right, so this is fine. But now when it's like this, and then I say to you, find me the vector C, such that that vector C is just make it like this time around. It's going to be B minus A. All right. So in this case, you could visualize it graphically, but I don't think I'm more interested in that now. Let's just find everything mathematically. All right, remember, this thing is going to have a y-axis. I did not draw it properly. It shouldn't go that far. It should stop somewhere here. And then this is going to be the x-axis. So this is going to be bx. This is going to be by. All right. Now let's see the other one. How will it look like? The x-axis is going to look like that. So this is ax, and then the y-axis is going to look like that. So this is going to be ay. All right. So this is how this thing is going to be. Then now, since we have this, we just want to find. Now let's see. Let's start with ax. Ax will be given by whatever a is, cos of 30 degrees. Ay will be given by whatever a is, sine of 30 degrees. What about b? Bx is going to be given by, now look at the angle. The angle is here, but bx is opposite the angle. You draw a line from the angle. It's opposite. It's adjacent. You only use cos when it's next to the angle. But in this one, it's opposite the angle. So you always have to look at the angle. Look at the side that you are looking for. If the side that you are looking for is opposite the angle, then you can't use cos for that. You have to use sine. So it's going to be b sine of 47 degrees. And then for y, this is going to be cos, because if you look at y is adjacent, it's next to this 47. So this is going to be cos of 47 degrees. Now, this is very important because sometimes the questions can be stated like this. What you could do also, you could actually use this angle here, and then you could say 90 minus, I don't know why it's doing that, 90 minus 47, then you'll end up with like 43 degrees. So you could use this 43 degrees, it's very easy. Then if you use the 43 degrees, if you wanted to use the 43 degrees, then bx was going to be b cos of 43 degrees. Hopefully you can see the difference. So if you use the 47, it is sine. If you use the 43, it is cos, because the x component here, it's adjacent to the angle 43 degrees. It's just next to 43 degrees. But the y component is actually opposite the 43 degrees. So therefore, this is by. This is going to be by. It's going to be b sine of 43. So you have to be aware between the two cases. You'll get the same answer. If you use b sine 47, you get the same answer as b cos 43. You get the same answer. But you have to know what to use. So I'll stick with this 47. Since I started with it, I will not use, but I was just showing you that you can actually use this as well. That's what I wanted to show you guys. All right. Now from here, we just simplify everything. So let me go back to my blue color. Okay, and then this is going to be equals to. Now what is b? B will be given by bx and by. All right. So it will be vector bx plus vector by. Remember, once you break it down into components, it looks like that. Minus, which is this minus. Open the brackets. Ax plus ay. Okay, let's just break everything down. It's going to be bx. So you must always start with the vector that you have here. So it says that the c is going to be equal to b. So start with b minus a. So minus a. So you must keep the equation as it is. right? Take the x, it's going to be minus ax, right? This is going to be plus by, and then this is going to be minus ay. Right, so you just multiply this minus, this is minus multiplied by ax is going to be minus that. Minus multiplied by ay, since it's a plus, it's a minus multiplied by plus, which is minus. So you have this minus ay. Right? Okay, so far it looks good. Okay, and then from here, everything else will just fall into place. For instance, this bx is going to be b sine of 47. Remember I said I'm going to use 47. This is going to be a cos of 30 degrees. Then this is going to be, everything is going to be in the x direction. Okay, now let's look at b. In actual fact, I have to go back. Let me go back. I made a mistake somewhere, so let me just go back and then I'll correct it and explain it properly. Right, and then I have to put all right, I'm just waiting for it to finish. Sorry about that. Okay, I have this, so I'll put this here. All right, now let's look at b. If you look at bx is negative, it's going in the negative direction. If you look at bx is going in the negative direction, so it has the magnitude of bx, but what direction is it going? It's going in the negative x direction. Right, and then there's a minus, this is the minus. What is ax? Ax is going in the positive direction, so the magnitude is ax and the direction is positive. All right, so that's good. Okay, so what about the other one? Right, by is going up, the magnitude is b. I don't know what by is, but it's going up. So the only thing so far that I know at this moment is the directions. What about this one? This is minus, and then what is ay? There's ay, it's also going up, therefore it's going to be ay. So it looks like this. Then when you simplify this, and this makes it possible for you guys to track and make sure that you don't make mistakes. I nearly made a mistake because I actually skipped this step, and these steps actually, if you don't skip this step, then everything will be on track, because from here you know that you're going to have minus, but what is bx? We said bx is going to be b, and he said that this is going to be sine of 47 degrees, and so this is the minus. This minus is the one that I took it out here, and everything is going to be in the x. Then there's the minus, and then what is this? This is a cos of 30 degrees. Put everything into brackets, take the x out. So if you were to take this x head out, you'll be left with minus bx minus that. So I trust you guys, your mathematics is fine. All right, let's just put a plus here, put a bracket. Right, what is by? By is going to be b cos of 47 degrees. Right, and then this is, remember the y we're going to take out, so we're going to take out the y. So this is going to be this minus, what is that? This is a sine of 30 degrees. Like now I don't have enough space, I didn't give myself enough space. All right, so and then you can simplify this. B is, I think it's, let me see, I think a is 20, oh, a is 60, and then b is 50. All right. Okay, so in that case, my b is minus, this is 50, minus sine of 47 degrees. I don't know why am I busy doing this type of mistakes. Now I'm writing 470 instead of 47. Okay, so this is supposed to be 47 degrees. minus a is 60, cos of 30 degrees. Everything there will be in the x. And then this is plus, this is 50, cos of 47 degrees, minus 60, sine of 30 degrees, and then everything is going to be in the y. Then you take the calculator and then you just group them. So what I will do is you first calculate this one, this term here, then afterwards you're going to calculate term there. So what I used to do sometimes do that when I'm testing my students, is because they'll be coming from high school with, they're having learned certain ways of doing this. Just to make sure that I drill this into them, what I would normally do when I set them their test, their first year test, is I would actually sort of force them to follow this, so that they know how to logically just think about this and actually just complete it. But you can use any method that you understand. So I normally teach it in a way that you should just break it up nicely and don't skip step. But there are faster ways you can do this. Maybe I might do a video whereby I say how can you just jump and do this maybe like in 3 steps, but then you are most likely to make mistakes if you do that. But then you could do that if you're confident enough. All right, so let's just calculate these values and see what we get. So we have minus 50, sine of 47, and then it's going to be minus 60, cos of 30 degrees. It's minus 88, it's minus 88 in the x direction. There's the x that stays, and then there's the plus. I know that it's going to be a plus or what. So let's first calculate it and see. And then it's going to tell us when it's going to be a plus or what. So let's find out what that field is going to be. It's 50, cos of 47, minus 60, sine of 47, and it's minus, so my hunch was right. I was reluctant to put a plus here, so it's going to be minus 9.8 in the y. Alright, so this is how my vector c, which is b minus a, is going to look like. Okay, so alright, so we do that. Then what we then do is you draw it. Remember, you must draw it. So it's minus 88 looks like that. Minus 9.8 is just very small, minus 9.8. So it turns out that my vector c is going to be a vector that looks like that. This is my vector c. So this is b, and then this is minus a. That's how the vector minus a is going to look like. This is incorrect. And then let me just go back. So this is just the x component of c. If you like to think about it, this is cx, and then this is cy, not a and minus b. I need to make that mistake again. All right, so luckily I can still spot them before I make them. All right, so that's it. All right, so that's good. If you want the magnitude of this, you know the story by now, how to get it. You just say that. Now this is negative, so I want to substitute the negative. I think this is a very good idea because everything is negative, so that you can say an example of how do I do a negative, how can I do a negative. So you say I did not include the negatives because even if you put a negative here, any number that you square is still going to be positive, so it doesn't matter. There's no need for you to put a negative. So this is that, and then 9.8 squared, that is that. So you have like 88.5. 88.5, I think it's newtons if I'm not mistaken. So that's the magnitude of c. So I've sort of changed in writing things like this So I'll interchange. Sometimes when I write the magnitude, I'll just say C, or I can just say the magnitude of C. It's the same thing, right? I'm saying the same thing. All right, and then if I want the direction theta, so if I want theta here, theta will be given by, now I have a negative and negative, so I'm not going to put the negatives. So I'm just going to put the y, which is 9.8. I'm going to put the x, which is 88. And then this means, so this thing actually is, this means. So if I say this means in maths, I write this sign, I'm saying this means. Therefore it's like this, because it's like this. So that's what I like about maths. You just get to say something without writing it. This is therefore, this is because. This means. So this means theta is going to be equals to, take your calculator and then you calculate what theta is going to be. All right, so I prefer to do these things live. I like teaching live in a way. It makes it feel like I'm in a classroom, and you get to think and you get to actually show the thought processes. All right, so the angle is very small. It makes sense why it's small. It's 6.4 degrees. It makes sense why the angle is very small, because this one, the x component is very long and the y component is very short, so this theta becomes very small. All right, so this is how you can do it, and it's very easy. And then you just say theta, you just say the vector c is 88.5 Newton, comma 6.4 degrees below the negative x-axis if you want. Or you could say you had to go to west and then south, so this is going to be south of west. So you could do that. So I'm not going to write it because we've been doing that over and over, and by now I think you guys should be quite familiar with. So we've subtracted vectors that are perpendicular to each other. We've subtracted vectors that are in the same line. We've subtracted vectors that are in the just basically they are at different angles to each other. So this is how you subtract vectors. The last one, let me just do a simple case, because sometimes you can get vectors like that. You can be given a question where they give you like that. For instance, they can give you the vector A and say that vector A is 3x, and then vector D is, and then this one, the y is 4y. They can give you vector B, not D. Then let's say this is 8.5x and then minus 6y. Now they could say to you, find the vector C such that vector C is A minus B. I'll do two things here to show you something. Alright, so what is A minus B? So you put A, which is 3x minus 4y, and then there's the minus, which is this minus. What is vector B? B is 8.5x minus 6y. Shows that. Now that's vector C. So which means that vector C, take all the x's and then you just subtract from one another. So it ends up being 5.5x. And then this is going to be minus 4. Is it minus? Yes, it's minus. So it's going to be minus plus minus, which is positive. So it's like saying minus 4 plus 6, which is plus 2y. Alright. Now let's say I want to find the vector D. So the vector C is like this, which is A minus B. So this is what A minus B is. What about B minus A? Right? So I'm saying find a vector B such that it is actually that one is B minus A. Well, you will say the same thing, but now you'll say B is going to be 8.5 minus 6y. This is supposed to be x. Right, let me just scratch it and then make some space and write it again. Okay, so I'm going to say this is going to be, what is B? 8.5 x hat minus 6y. That was what B is. Minus, which is this minus. And then A, what is the vector A? The vector A is 3x plus 4y. Okay. And then sorry about that. All right. So what is that now? So you're gonna say 8.5 minus 3. You still get 5.5, but it's positive now. And then when you say minus 6 minus, see now it's gonna be minus 6 minus 4. You see, so it's interesting. Now you're going to have minus you're going to have minus 10y. All right. So in principle, you have a situation whereby your a minus b is not going to be the same as b minus a. So right. So it just depends on what you have, and then that's what you're going to get. Right. Okay, so that should be fine. I think I made a mistake here. This should have been a plus, so which makes this a 10. I was thinking, what did I do wrong? Because I'm trying to think something is wrong. This is supposed to be a plus, and then a minus is supposed to be here. Then this is 10. So what you do notice is that b minus a is not going to be equals to a minus b. So it's not like the plus, but a plus b is actually going to be the same as b plus a. So it wouldn't matter how you add the two vectors. If everything is positive, it doesn't matter whether you start with a and then b, or you start with b, it will be the same. But when you're subtracting them, it matters. But interestingly, what you will find is you will find that you will find that a minus b is going to be the same as minus b minus a. So it will be a minus of that. Look at this answer. C is minus 5.5 and then plus that. And then this one, where there's a minus, there's a plus on this. Where there's a plus here, there's a minus on that. So you can see that the signs actually have changed. So that is why that you can actually find that they are like that. Alright, so you can just go to textbooks and I'll teach more about this when I start teaching calculus-based physics, because there I will extend it into 3 dimensions. I will teach other concepts, and then I will start dealing with the rules for whether something is associative, and then so I'll just be dealing with all of those rules, right? Those mathematical rules or deductions that we actually come up with to say, okay, we deduce from this, and then this is what we find. I'm not going to deal with this now for this one. I think if you're doing this type of physics, which is normally the physics that you find in the health sciences, in the applied sciences, in the engineering, like your B-Eng, not your BSc, like your B-Eng or your diploma in engineering. This is the type of physics that we'll teach, so we don't need to worry about that. All right. Okay, so I think this is fine and this is cool. From here is very easy. If you want the magnitude, it's very easy. So I'm not going to do the magnitude in the direction because I've been showing you this over and over. So you should be able to do that by now. Otherwise, guys, I think this should be enough for this video. And then I'll see you guys in the next video. Cheers.